Welcome to the Fluid Power Lab. Today we are diving into the invisible force that drives modern industrial automation, compressed air. In this experiment, we will uncover the fundamental pneumatic components and learn exactly how to harness air pressure to create controlled mechanical movement. Think of a pneumatic system like a high-speed plumbing network, but instead of water, it relies on pressurized air. The muscles of our system are the actuators, which convert the energy of compressed air into mechanical motion. This motion can be a straight line linear push or a rotary rotation. But air needs direction. That's where directional control valves or DCVs come in. They act as traffic cops and are used in pneumatic systems to control the path of airflow. The secret to mastering pneumatics is speaking its language. Every directional valve is described by two crucial numbers. The first number tells you the number of ports, which are the openings for air to enter or exit. The second number represents the number of positions or distinct switching states. So a 3x2 valve simply means 3 ports and 2 positions. Once you understand this code, reading any circuit becomes a breeze. Before we turn on the air supply, we must follow a strict safety checklist. You must ensure correct connection of all ports. Always check for any pressure relief valves, check valves, or emergency shut-off features in the circuit. Safety first. Now that we know the theory, let's step up to the trainer kit and bring these components to life.
Hello everyone, in this video we are going to learn about the pneumatic trainer kit, and this is the first experiment that we are going to be conducting in the pneumatic trainer kit. This is the basic operation. We can see this whole panel. In this panel we can connect any of our pneumatic devices. Okay. This is the FRL unit. From here our main from the compressor the air is going to come here and through this FRL unit, that is this is the FRL unit, that is filter, regulator, lubricant. Okay.
Let's pause and clarify. The FRL unit stands for filter, regulator, and lubricator. Why is this the heart of your pneumatic system? The filter removes moisture and dust from the compressed air. The regulator sets the safe working pressure. And the lubricator adds a fine mist of oil to prevent internal friction. Without FRL, your costly cylinder and valves will quickly wear out and fail.
In this experiment, we are going to use double acting cylinder. Okay, this is the double acting cylinder. We have two inputs, like this is for the forward actuation because the air will be given here. So when air is given this side, it is going to push our cylinder forward. Okay, so this is forward movement, this is backward movement. So here when we give air, it is going to push the cylinder inside, that is it will retract. This is my double acting cylinder. These are my flow control valves. This is only for this cylinder. Okay, I don't want my cylinder to actuate immediately, like give a hard push. So what I'm going to do, I'm going to regulate my air flow from either of the sides. Okay. Next up, this is my 5x2 directional control valve. This is lever operated. 5 is, it has got 5 inputs and 5 controls and 2 positions. So you can see this is one position, it goes in the middle because it is spring written, and this is the another position. Okay, so it has got 2 positions and middle is the neutral. This is 5x2 directional control valve.
Okay. Let's break down exactly what 5x2 means. It signifies 5 ports and 2 positions. Port 1 is the main input for incoming air. Ports 2 and 4 connect to the double-acting cylinder. Crucially, ports 3 and 5 are exhaust ports. Why do we need exhausts? When fresh air pushes the piston forward, the old air on the opposite side must escape. If you block the exhausts, the cylinder jams completely. Proper port routing is vital.
Okay, in this is the main inlet where the air is going to go. This is the main inlet. These are our two, what we say, two outputs or say two inputs where we are going to give it to the cylinder. And these two are the exhaust that are given. Okay, this is the manifold. Okay, manifold is nothing but you give air and take multiple outputs. I mean, take from the multiple holes. Okay, these are the pneumatic wires that we are going to use. Initially, I'll tell you how to assemble the components on this plain board. Okay, there is a notch here. Okay, you have to press this like this. Okay, you can see here behind. When you press, it is going to sit on these slots. Okay, I'm pressing this blue. So I'm going to press, hold it, and I'll just see and place it in the slot and leave it. It gets fixed. Okay, this is how we are going to place our manifold. Now I'll be placing my double acting cylinder. Okay, you can see here there are blue color circular shape 3 dots. Okay, these will rotate like this. Okay, we have to rotate them and fix it. Behind you can see these are the nuts. Okay, that will sit in the slot. When they are like this, it will not sit, but when they become vertical like this, sorry, horizontal like this, they are going to sit tight in the knot, this notches. Okay, so this is how we are going to place our cylinders. And I'm going to rotate my these blue color circles so that it sits tight. Okay, once you feel it in your hand that it is going to be tight. Okay, it is in the either of the directions like this and like this. Okay, and you will feel it that it is sitting tight, then only you leave it. Okay, do not leave it loose. This is my double acting cylinder. I have fixed it. Now I am going to fix my directional control valve. This is also having same as we fixed the manifold. That is, we need to hold the blue color, pull it tight and place it in the slot. Okay, you can see it is placed. Now I am going to take the air from the FRL unit. This is a kind of big hose. Okay, here you need to just insert it, press it tight till you feel that the wire is not going inside more. Okay, just press and just check, and when you pull it back, it will not come out. Okay, when you want to remove it, you have to, this blue color notch is there, right? You have to just press it and pull it out. Okay, and do not use this small cables. Okay, small pneumatic pipes. So this is the difference between both. This is through FRL unit, this is through manifold and through the your whole connection that you're going to do. Okay, and here also you can see, you can observe this hole is different other than these. Okay, I'm going to put it. I'm going to take an input, use any of the slots. This is my input. Okay, you can either place your device like this or like this, because you need to give these to the cylinders, right? On your screen you can see the circuit connection for this, so according to that you have to do. So these two buttons will be connected to the cylinders. So however you feel convenient, you can place your device. Okay, this is the final connection. Before you give the air supply, you need to check with all your wires. Pull it, see if they are tight enough, okay, so that there won't be any air leakage and there won't be any accidents.
The trainer rightly warned about accidents. The most common pneumatic hazard is called hose whipping. If a high-pressure hose is not pushed completely past the internal locking ring, turning on the main supply will cause it to blow out and whip around violently, which can severely injure your face or eyes. Always perform the push and pull test to guarantee a secure grip. Never compromise on safety in the lab.
Okay, everything is tight, everything is firm. So we are all set to give the connection. Here to your FRL unit, you can see this. This is the valve that will stop the air supply here itself, and this is the valve will also release the air supply. So you need to release it. Okay, I released my air. You can see the air pressure, and now we'll check. So this is my retract position. So the air supply is going here. This is my forward position. This is how we are going to manually actuate our cylinder. Okay, I'm pressing and I'm leaving. It is going back to its position. I'm pressing and leaving back. It is coming back to its position. You can check again. I'll just hold these wires here. Press down. It is moving forward. Leaving, it is staying on its position. When I'm giving it here, it is retracting, staying on its position. So this is my manual actuation of the pneumatic circuit.